My name is Ramesh Naik. I have completed my M Pharmacy at IIT BHU Varanasi. Today's topic is on micromeritics. So what are the different means of expressing the particle size? Means the particle size in which meters we can measure. Means millimeter, 10 to the power of minus 3 meter. Micro, 10 to the power of minus 6. Nano, 10 to the power of minus 9 meter. Next one is picometer, 10 to the power of minus 12 meter. Next one is femtometer, it is 10 to the power of minus 15 meter. Next one is different particle size range. If particle size range is greater than 1000 micrometer, we can call as a very coarse particle. Particle size greater 300 to 1000 micrometer, we can call as a coarse. Particle size 180 to 355 micrometer, we can call as a moderately coarse. Particle size 125 to 180 micrometer, we can call as a fine particle. Particle size 190 to 125, we can call as a very fine particle. Very fine particle. Next one is in which form? In means particle size can be measured in diameter. Majorly 3 types of diameters are there. One is Martin. M means middle of the particle. F, it means it's far away from the middle. See, projected area diameter means the whatever initially we have taken this is the particle, then I have drawn a hypothesized circle by putting a pointer here. I have drawn the circle around the particle. Then whatever this circle, the circle of this diameter we can call as a projected diameter. Then particle diameter, the particle diameter in the middle we can call as a Martin's diameter. Next one is Ferret's diameter. It is present at tangents. Tangents means this is one tangent, this is another tangent. Tangents means opposite side, opposite tangents. We can call as a Ferret diameter. We can call as a Ferret diameter. See, distance present between the two tangents on the opposite side of the particle. On the opposite side of the particle, we can call as a Ferret diameter. Next one is the length of line which bisects the particle image. This is called a Martin diameter. Next one is projected area. I mean, it is the diameter of the circle that is having same area as that of particle. This is the diameter of the particle. This is diameter of the circle. This is circle having the same area as that of this original particle. Next one is methods for, see what are the methods we are using in order to determine the particle size. Microscopy, sieving method, sedimentation method, and conductivity method. In microscopy, particle size range should be 0.2 to 100 microns. By using optical microscope, what we can determine Ferret to Martin and projected diameter we can measure. Sieving 50 to 1500 micron particle size by using mechanical shaker. Sedimentation 1 to 200 micron by using Anderson pipette. It depends upon the gravitational force. The particle will fall at the bottom of Anderson pipette. That depends on gravitational force. Here what we can measure, Stokes diameter we can measure. Next one is conductivity method. Here 0.5 to 500 microns particle size particle range of we can determine conductivity. Coulter counter or Rayok or HIAC. Coulter current also known as this one. Next, here what we can determine equivalent means particle volume we can determine. By using that we can measure the particle diameter. So where the particle size plays key role means lymphatic targeting, gene delivery, aerosol in the aerosol, intraperitoneal drug delivery, oral granules, oral depots, brain tumors in case of brain tumors, IV means intravenous and intramuscular, nasal nothing but aerosol, transdermal and ocular. Next one is importance of particle size in novel drug delivery system. See, in order to enter a particle into the tumor, there is a fenestration, nothing but this gap present between the this is the blood vessel, this is the blood vessel, these are the endothelial cells. This one endothelial cells. The gap present between the endothelial cell we can call as a fenestration. So when the particle size is 10 to 100 nanometer, 10 to 100 nanometer, then the particles will easily pass into the tumor cells in case of cancer. If the particle size is greater than 100 micro nanometer means, then the particle will not move into the tumors. It is not effective in order to treat the cancer. Particle size greater than 100 nanometer, it is not useful because this will not enter into the cancerous cells. Next one is in case of transdermal drug delivery, the particle size should be 100 to 200 nanometer, 100 to 200 nanometer. And in case of nanoparticles, the particle size should be less than 0.5 to 4.6 micrometer. See, less than 0.5 to 4.6 micrometer is needed. Then only the particle will escape from this phagocyte. This is a phagocyte, escape from phagocyte. If it is having more than 5 minutes, the nanoparticle will easily entrap into the phagocytes. Then easy means immediate clearance of nanoparticles will be there. So this is importance of the particle size. Okay, thank you.